Thank you so much for joining me for this interview. I just wanted to ask you like a few questions about your profession.
It's my pleasure.
Okay, what industry and company do you work for and what is your title?
Okay, I am a senior director at a startup called Fungible, and we are doing. We started with making a chip for the cloud industry, but we ended making the whole box that can fit it into the data center, so that you can virtualize the storage, the compute, the GPU. So you don't need to have a big hard disk on your computer. You don't need to have the whole compute resources on your desktop. Uh, it can all be virtualized. The box can be placed millions of miles away, and you can still reach it, and you'll feel that if the box is there, the storage box is there, or the compute box is there. So that is called virtualization of compute and storage.
Can you describe to me what your overall like job responsibilities are?
My responsibility, see, it's a teamwork, right? So I help in architecture of the chip, that how we should architect it in the way to get high bandwidths to achieve our final goal. And then comes implementation. Now, whatever you have architected, how do you put that in gates, so such that you can put it in the chip? Then to make sure that you have implemented something, but you want to do a complete verification that what you are implementing is correct or not. And nowadays, with deep submicron technologies, the cost of the mask means the chip. Chip, if you see inside, it has many layers. So those are called masks. The cost is really high. So, say for example, what we are paying is about $1.8 million for the first chip at the time it goes out. So we have to make sure it is completely verified. The bug doesn't stop there. When the chip comes back, you have to still make sure that it is what you architected, what you implemented, and then apply the real life scenarios, the real life traffic, to make sure it is doing what you thought about. Uh, After this, the chip goes to a potential customer. They can try their traffic through and see that is that what they want. So it's a whole process. And the cool thing about working in a startup is you don't stop anywhere from beginning to the end. If the chip or the box is not successful, then you are not. So I play a role in all of this, because the way my career went, I have worked in all these stages of the chip, starting from the architecture to the to have the actual chip back and to make sure that it works.
What does like a typical workday look like?
Oh, that is interesting. Um, That's very interesting. So, frankly speaking, after we drop off the kids and all, I'm online at night, at 9, and for first thing is to just uh, uh, make a result that what do you want to get done in that day, and that depends on in what stage the chip is. And then you split that into micro tasks, and you make sure either you're working on it or the team is working on it. uh, as far as work day or the weekend for a startup, it's the same. So the work takes the priority.
What kind of skills or mindset is required to deliver well in this job?
Experience helps a lot. So to give you a history, I have done all kind of chips. So starting from processors, and in processors also certain modules, like you might have heard caches and all, and did different type of caches. I have about 35 patents on the chip architectures and all. Then after processors, we did the network accelerators. Means that to have start say if you want to access internet from home, then how it goes about, what chips it goes about. So that also helps. So after working in different type of chips, the experience you get is very, very invaluable. So it is not a particular skill that helps, but what kind of issues you have seen in the past, how to take care of them, blah blah blah. That helps to make sure that what you do is good.
Did you always want to do hardware, or were you ever interested in software?
Oh, that's a very interesting thing. So I have never confined myself to a particular field. I don't put myself in a silo at all. So at the time I started, I, as I told you, I've done my engineering and instrumentation. But instrumentation is more of processes, heat, this and that. But what I found interesting was programming. I used to do antidotes for antiviruses, antidotes for viruses. And then my actually first job was to break hardware locks, software locks, be more of a hacker because I found that really interesting. So I after we did that, I got into organization in India, HCLHP, which was doing very interesting stuff. And they wanted to get us started on chips and all. I have never done chips in my college. How to do them, what to take care of, no. So I've changed my field as needed. I've never confined myself to any particular aspect of the chip or a particular kind of architecture or whatever.
What are some things that you like enjoy about your job?
I love everything about my job. Everything. From day one, I'm not kidding this way. I've never forced myself to work. No one has forced me. None of my bosses, nobody. Actually, the feedback I get take it slow. There's no hurry. It's just a project. But this is so interesting. It's my passion. So the passion is something that drives you. It doesn't matter that it is a work or a game, a sport, or whatever. You should be passionate about that thing, or you should not do it. That's what I believe.
Is there anything you don't like about your job?
Nothing. So one thing I did not like earlier. So from 92 to year 2000, I used to work for big companies like Hitachi, BPM, Sierra, and all. There I felt that I was a very small part of a big enterprise, and that's the part I did not like. So therefore, since year 2000, I've been working in just startups. And the best thing about startups is you can spread your wings as much as you want. Whatever you want to learn, there's no confined silos, so that helps a lot. So I love everything about what I do.
What skills did you have when you started this job, and like how did they develop?
Oh, that's very interesting. I told you that the skills which I started were very different than what I'm doing right now, and I had to acquire the skills, and that is life, right? The things change. Like at the time I started on chips, the first technology I did was at 60 nanometer. I say nanometer means if you have a wire inside the chip, what will be the thickness of this? Now with what I'm working on is 5 nanometer. So that means that big of a chip at that particular time we will be that small of a chip. So with the technologies changes, you have to always keep yourself updated on the tools, on what to do and what not to do. So
Was there like any online certifications that you found useful?
I don't believe in that at all. I, I really believe that if you come to know about a particular language or a particular thing where you find yourself, yes, this is me, I can do this, just go on Google, do what I believe is do it on your own because then it's your schedule and you can get it done. And once you do it, it doesn't matter how you learned it, right? So
How did you like learn what you didn't know? Do you ever feel like fearful?
on the job, I just see that is the thing. You have to be passionate about things. Once you are passionate about things, then you learn, and then you have to foresee in 5 years where do you see the industry going? And that is what you have to adapt. Whosoever can adapt goes sails through. Who cannot adapt, they get stagnated and they're thrown out of the industry.
Can you tell me a little bit like about your educational background?
I was not that bright of a student, but the thing is, one thing I had was that if I put my head to something, I used to complete it no matter what, no matter how much time it takes, no matter how hard it was. So that particular aspect really helped. So I did my schooling in Delhi, and after that I did my engineering through Government College Pune, and I came here, and I had this pact with my dad that if I can get the first job and I can be paid as much as a PhD can, then you'll not force me to do the masters and all. And we agreed to it. I kept my promise, and he kept his promise. So, academically, I'm not as that strong, but what is the uh, uh, real life execution that I know how to do.
You were speaking about like Hitachi before. What are like some of your other job experiences other than this current startup?
So here in US, I started with Hitachi. We did processors, and the processes are being done from a long time. But the key was to speed them up. So at Hitachi, my main contribution was on the architecture of caches, how to do the caches differently that you can get speed of it. So the architecture came up with, and the cool thing about architecture and implementation, the difference between architecture and implementation is architecture solves the problem, and that you can implement in different nodes, blah, blah, blah. So in Hitachi, I worked on processors. After that, I got bored with processors. I worked on processors for about 8 years. Then I went to a startup, and it was finally bought over by PMC CRM. So at that time, I changed my field completely from processors to network accelerators, and I did that for a few years. Then I got bored with that. Then I wanted to do the actual transistor circuit design on the chip. So I went to this startup called TRAM. We did a single transistor RAM cell. It was so unique. Worked on it for a few years, got bored with that. Then did IPs and blah, blah, blah. So that's how it went. So I mostly have been with startups after Hitachi.
Do you have any advice for like other kids who are interested in pursuing computer science?
Advice. Just uh, chalk out your path, see that what it takes. Uh, Academically, learning something is important, but not the ultimate thing. As in, I'll tell you an example. While doing my 11th, 12th, um, yes, academics was one thing, but I was very interested in C programming. At that time, that was the thing. There were no exams in the 12th grade for that, but I just learned it out of, yes, this makes sense to learn. I, I took classes, I did whatever, and that helped me a lot throughout. So just you have to find your passion. That is the most important thing. See that what is in the industry, what the industry wants, and see that can you do that or not.
Can you tell me a little bit more about like the chip design and how it fits overall with other hardware in this industry?
Yeah. So if you think what is there in the chip, so if you implement whatever there is in the chip in a box, that box will be big, very big. So what chip does is it condenses it all according to the technology you want to go with. As in, I'll take a small example. A transistor, the basic transistor, will be that big, and in the chip, this transistor will be of the size of say 10 nanometer. So 10 raised to minus 9 meter. So how you have condensed this thing? Same thing goes outside if you put a transistor on a board and you draw a wire, that wire can be of whatever length. But now if you do on chip, you can have a smallest wire as 10 nanometer. So what you're trying to do is whatever circuits you're trying to make on the board, you're condensing them on the chip. And when you condense the thing, then the current doesn't have to flow on the whole board. So your power goes down. You can put more functionality in, so on and so forth. This where it helps. Just to give you an idea, the last chip we did, it had 10 billion transistors. Now, if you want to implement something of 10 billion range on a board, that will be the size of San Ramon.
Can you walk me through like the steps of chip design conceptually?
Absolutely. So the first thing we start is with the spec, that what this chip is supposed to do. Now that's a bigger picture what the chip will solve. Then you split that functionality into small pieces. Those are your blocks. That these blocks, when you architect them and put them together, they will uh, work together to achieve your functionality. Then you further split those blocks into sub blocks, and then you attack that particular way. Then you start from architecture, you go to micro architecture. Now this is a big plan. What is a smaller plan? And for microarchitecture, you get small blocks and you architect those blocks again. So you're architecting the micro architected blocks. Once you know what is the functionality, then you start to code. So this coding, you have to keep in mind the coding we do is called a Verilog coding or the RTL coding. Generally, at the time you code in C, you execute one instruction, second instruction, third instruction, and you go like this. The difference here is these are circuits. So all of these are executing in parallel. It's just so your coding style or your way of thinking how the coding works changes. So in short, you have to implement the whole circuit on the chip. Once your coding is done, then we have a different team called validation team, which sees that what you have coded makes sense or not, or is it compliant to the microarchitecture you wrote. So this, you're still at the block level. So you make sure that yes, whatever was architected went as coding, has been verified. Then now, since the mask making is so expensive, you want to run the actual OS on it to make sure, operating system or software on it to make sure. So at that time, you do emulation on the RTL. Once you're very confident that this what I've coded is what we wanted and it'll go as a chip, then you do something called a tape out. Tape out means here is the mask, make the actual chip out of it. So that is not done here, that is done in a fab. Fab doesn't know what is there in the chip. They are just seeing the transistors and the wires, and they're just implementing what you gave them. So after 5 months, the chip comes back. You have to plan ahead while the chip is being made, is that on which board it can go so you can test your functionality. So by the time the chip comes back, your board is ready, you plug that in, and voila, now you go get two things. Either it works or it partially works. If you have a well experienced guys, it will work. Like all the 4 chips we did in our startup, every chip worked the first time. But if you don't have that kind of a team, then you'll find bugs. And when you find bugs, what are bugs? That this is the functionality you wanted, but you did not get this, rather than got this. So something was messed up in the validation process, that you did not do it right. So then you put processes in place that this kind of thing should not happen again. So at the end, you need to have a fully functional chip.
Thank you so much for
Yeah,
this
it
interview.
was all over the place. I have no experience of any interviews at all. The only experience I have is to just get into a room and get the thing done with the team. So,
Thank you.
yeah, most welcome anytime.